So welcome to the meeting. We're very happy to see this nice turnout for an avocado meeting. I hope that means that there's a lot of interest in avocados. And I'm Mary Lou Arpaia. I'm a cooperative extension specialist. I'm based out of the Carini Egg Center. My home campus is at UC Riverside. And I won't tell you how many years I've been working for the university, but it's been a long time. And I work on citrus and avocado. So I know many of you, I recognize many of you from working on citrus. But I also work on avocados. And we have a very full agenda. And because we have a full agenda, what we're going to be doing is we're going to hold the questions till the end of all the presentations. And then we'll have an open roundtable. We have one speaker who's coming to us from Israel, our known dog. And he will stay online and answer any questions related to his talk then. So this meeting is the meeting here at Lynn Cove is the first time we've had a meeting, but the three organizers of this meeting, first is the California Avocado Commission, and it's the state marketing order. And if you, as a grower, if you become a grower to avocados and you market your avocados, you will be paying an assessment to the commission. And today we have the chairwoman of the board, Rachel Kimball Lanen, and right there. And we also have the president of the commission, Ken Melvin, who actually lives here in Visalia. Wow. What's up? The other organizer of the meeting is the University of California Cooperative Extension Service, and we have Ben Faber, who's the speaker, who is on the organizing board for that. And then the third sponsor is the oldest organization for avocados in the state. It was founded in 1915, so over 100 years ago, and that's the California Avocado Society. And representing the California Avocado Society today is Consuelo Fernandez, the president.
Thank you very much. Thank you for being here. We're very excited to see so many people coming and so many people interested in the avocado industry. I wanted to thank the foundation sponsors for the California Avocado Society. Those are Brocco Nursery, Index Fresh, AgWest Farm Credit, Westphalia Fruit, Del Rey Avocado, McDaniel Fruit Company, Nutrien, Mission Produce, Westpac, and PhosGrow 05636. I also want to give a special thanks to our seminar sponsor, WiseCon. And without any of these sponsors, we wouldn't be able to make these seminars and to communicate with our growers. So thank you very much to our sponsors. The California Avocado Society has their main objective is to share research, scientific knowledge, innovation, practical field experience, and industry info to our growers. And we do this through seminars, annual meetings, newsline, and the quarterly magazine. So that's why we strongly encourage you to become a member of the society.
Thank you, Consuelo. So I urge you to become a member of the society. They have a weekly newsline, which gives you the pricing and all kinds of other interesting, useful information, not interesting and useful. And I have to say that when I got hired at UC Riverside, my predecessor, Bob Platt and John Pearson, both told me within a week of me being hired, I needed to become a society member, and I've been a society member since then. So anyway, we're going to move right directly into the first speaker is Tapan Pathak. Did I get your pronunciation? Great. And I'll let you introduce yourself, but he is an associate professor and extension specialist at UC Merced.
Thanks, Marilu, for inviting me to speak to this meeting. My name is Tapan Pathak. My area of expertise is in agricultural engineering and climate science. So I work in that interaction of how weather and climate interact with the crops and how we see impacts on different aspects of agriculture. But today I'm going to talk more broadly about historical trends that we have seen in California. What are the projections in the future, and what are some of the short-term forecasts? And then I'll end with uh, decision support system where we are integrating climate and weather information and provide decision support to various crops and commodities. And so it's kind of mixture of everything related to climate and weather. So here is the very simple, colorful map of how 2026 has been so far compared to the historical records. On your left is temperature record, maximum temperatures, and on your right is precipitation. If you see on your left the maximum temperature, you see a lot of orange and yellows, which tells us that temperature has been a little bit warmer than long-term normal. And the long-term normal is typically 30 years average, and this is a moving average. So, in this case, what you are seeing is current year compared to last 30 years. So from 2020, 1990 to 2020, something in that range. And temperature has been warmer. If you look at the Central Valley of California, is anywhere from 4 to 6 degrees warmer than normal, and yellow is between 0 and 2, right? And so there are some patches where it's a little bit more warming trend, but in general has been a milder, warmer winter so far. In terms of precipitation, we are a little bit wetter than normal. If you see, all the reservoirs are at capacity or exceeding capacity in some places. But in general, it's been greener, which is wetter by a few inches compared to the long-term average. And this is, in that case, it's comparing to the wet season, like it's a water year, not just the start of the season. And this is a next 3 months of temperature outlook. There is no reason of doing the precipitation outlook. Everybody knows what's going to happen. There's not going to be any rain. But for temperature, you see different contours here. Now there is a darker yellow or orange moving all the way to. That doesn't mean that the darker part is gonna be more warmer than the lighter part. Is kind of the way this images are produced. It only tells us that there is more confidence in saying that this region is going to be warmer than normal. Make sense? So, but in general, you see California is going to be in that warmer than normal range for next 3 months. And if you've seen some of the forecasts for next couple of weeks, it's going to be hotter. So moving into historical records here. Now, this is changes in temperature in different parts of California. So if you look at here, Sacramento Delta and San Joaquin Valley, this region and this region, if you look at on the bar, blue bar is the minimum temperatures and red bar is the maximum temperatures. And this is a degree increase per century. So roughly on an average, minimum temperature has been rising at the rate of 2 or 3 degrees Fahrenheit per century, per 100 years in that region. Now, if you look at the south coast or southern interiors or even desert region, their minimum temperature is way higher than others. But in general, rate of increase in minimum temperatures has been substantially higher than the maximum temperature across California. And this is historical records, not the future projections. And I can talk about a lot of consequences related to why minimum temperature increases are of a concern. Okay, so this is a precipitation record, and this is composite for the entire state. And this includes historical as well as future. Now, when I see this, I don't see any particular trend. This is more of a zigzag, but no clear trend. So there is no real consensus in the modeling community in general to whether we are going to be in a wetter or drier future for California. But there is more confidence in saying that, irrespective of that, we'll have to deal with both extremes as we move into the future. So we'll have to be prepared for flood-like conditions as well as drought conditions, and those, the magnitude of those are going to be higher in the future. Now, the other confidence that modeling community has is in saying that, irrespective of amount of rain that we get, we are going to receive in overall wet season is shrinking. So even if you get the same amount of rain, it's going to be happening in that shorter time frame. So you can expect more extreme single day precipitation type of event in the future. And this is a snowpack, which is our natural water storage, as we all know, in the Sierras. And because of warmer, milder winter, and you start seeing more and more earlier snow melt, and also in general snowpack reduction. So you would expect anywhere from 50 to 70% reduction in the snowpack as we move to the future. Another big concern is related to extreme heat, right? And so we've been especially in the Central Valley, we have been seeing extreme heat events every summer these days. And if I look at this graph, which is telling us that for this region, I just picked this region to see what is the upper threshold of the maximum temperature. So in this case, the 98th percentile would be in the range of 104 degrees Fahrenheit for this region for 30 years window, which is 1960 to 1990, right? So on an average, you would have 4 or 5 days, give or take, when temperature goes beyond that in that historical records. If as we move into the future, we would expect 40 to 70 days where temperature is going to be above that 104 degrees threshold for this region. And there is a lot of confidence in those kind of projections, because when it comes to temperature prediction, there is much more confidence than the rainfall in general, because of the complexity of how models work. And again, I think these are just a very general estimation, and every model, there are 30-40 models, and every model have a different range. But the main take home is every single model is showing the upward trend. So I think that's something we'll have to deal with as we move into the future, to how to tackle extreme heat for different crops. And not just the number of days is a problem. The also issue is timing of those extremes. Historically, most of the extreme heat is populated in that, like June, July, August, summer, typical summer months. As we move into future, those June, July, August will get denser, which means that you'll have more and more extreme heat conditions happening during that summer. But then extreme heat could start as early as May and could go as long as September and October as we look into the future year. So there is a concern for crops, and then there are also concern for farm workers who are working in the field, and so overall timing to be on the ground might get impacted by this extreme heat timings. A quick snapshot, like we talked about, we seen how temperature has been going up, what are the uncertainty around rainfall, and then extreme heat and the snowpack. Now let's talk about some of the potential implications for agriculture, right? How all these changes are going to affect agriculture in California. So these are farmers' views, and so we've been serving farmers in one of my projects funded by U.S. Department of Agriculture. And we did a statewide survey, and we also did several focus groups. And one of the focus groups was on avocado growers. So this is kind of mixture of all. I haven't been able to extract for commodity specific, but if you look at this bar chart, and no surprise, right? Like, when you talk about the concerns, water is the biggest component of it. Water availability, groundwater decline, crop stress because of the water uncertainty, drought severity. These are all water related concerns that grower responded they are very concerned about. And also extreme heat, pest pressure, wildfire, smoke, depending on which region you're growing your crops in. And so, these are the types of responses we received from growers on what's in their mind about impacts of climate. On a positive side, there are certain crops which are very frost sensitive, including avocados and citrus. For if they are exposed to frost for longer period of time, there would be significant damage to them. Now, with minimum temperature increasing, in general warmer trend that we are seeing, what we have experienced or at least modeled is like overall frost exposure is significantly reducing in the future. And again, it doesn't mean that some years you would not get those frost. You would still have those year-to-year variability where frost might hit after flowering or bird break happens, right? And so that's a natural variability that would still be part of it, but general overall trend is towards less frost in the future. So, now there are many areas that could potentially be open for growing crops which were previously frost sensitive in some parts of California. And so this is the future projections, and on your left is historical years. And as you can see, last spring freeze is declined, so it's shifting earlier and earlier. And this is like location specific, and I'll talk about those tools in a minute. And again, length of the growing season, which is like last spring freeze is shifting early, fall freeze is shifting later, and so you have longer frost-free season, and red means it's like that part is growing. And again, this is the comparing only two normals. The other big impact of climate is on pest, and how, so similar to crops, when temperature is warmer, the pest cycles are working more rapidly. And so there are so many implications, and I think this paper summarized some of the potential impacts of climate change due to pest. And so increased number of generations, expansion of geographical areas, outbreaks, overwintering. So frost-free season is a good thing for some crops, but it also invites more pests, right? Like they can survive the winter. And synchronous issue with the host plants and also the enemies. My team worked on this navel orange worm, which is a major pest for walnuts, almond, pistachio. So it's a nut crop specific pest, but this is the most damaging pest I've heard from entomologists. And so we modeled this. What we found out, generally, I don't want to go into detail, but just that the idea was that with this increase in the both minimum and maximum temperatures, the biofix for this pest is expected to occur sooner and sooner. So typically, if it is mid March, it might start early March or even into February, where they can start their biofix and so they start growing their generations faster. And as a result of this, for this particular pest, historically there were few counties where you would expect one additional generation, which is fifth generation, in one or two Southern California counties, Kern and Kings, or Tulare, that region. Um, by 2100, entire valley is expected to see that additional generation. Now the problem with having first generation to second is you have certain increase in pest, but any generations after that, you are increasing the number of pests in an exponential range, and so I think it adds more pest pressure. Same is for other pests. So then we extended this work for codling moth, peach twig borer, and oriental fruit moth. So these are some of the relevant pests for some of the tree crops, not specific to avocado here, but just to get an idea that every pest has a growing degraded model similar to crops. And in theory, if the temperature is on a warming trend, you would have those kind of linear relationship to how it's affecting pest cycles and how it is ultimately affecting the crops. So my team is also working on creating really crop specific stressors, indicators, where not just looking at the temperature but also the phenology, and in combination of that, what are the changes that we are expected to see in the future. And just give you an idea, and this is similar to the extreme heat, the graph that I showed. In this case, temperature greater than 38 degrees Celsius, which is roughly around 100 Fahrenheit, in that range. And this is during the growing season. So, approximately March through October. So in that time frame, number of days where temperature is going to be beyond that 38 degrees range is historically it was between 0 and 25 range, moving into 25 to 50, and towards the future 50 to 75 days where temperature goes beyond that. Also, every crop has their optimum temperature range, within that range, they have optimum growth. And if you consider for any particular crop where that optimum growth range is between 13 and 21 Celsius, sorry, I did not have the conversion to Fahrenheit here, but you see, these are the number of days where it's within that optimum range and slowly declining. So the optimum temperature window is declining because of the warmer regime that we have. So this is the last part of my talk, and this is again about how we know these things are changing. We know that there are risks involved, but then given this information, and there are many adaptation mitigation measures available. If we have this information readily available ahead of a time, can we use it for managing risk better? And so we build this online free web-based decision support system. It's called CalAgroClimate, and it's a free resource for California. So feel free to access it, and some of the tools that we have. We've been adding more and more tools to this, but currently we have heat advisory, frost advisory, crop phenology, pest advisory, and agroclimatic indicators as a suite of tools that in the system so far. And if you have a weather station, great. You can get data right away from the weather station. That's the best data. But it's not often available in many parts where you want to see how weather is changing. If you don't have a weather station, the next best resource is gridded data source. So this system is created in a way that they combine all the weather stations and come up with creating grids where you can click anywhere on California, and then you would still get reasonable quality data, which you can rely on. And so the free resource is 4 kilometers by 4 kilometers. the paid resource is 800-meter resolution. So in CalAgroClimate system, we are using 800-meter resolution, which provides a little bit more finer resolution, better quality data, and so that's what we are using it in some of the tools. Now the frost advisory, the way we structured is like, when your crop is exposed to frost for 1 day, 2 days, if it is going beyond 2 days and consecutively, if it is going to be below that threshold, then the frost exposure is a risk is higher. Do you have a question? Oh, okay, all right. And so that's why you see the darker color represents there is more risk than the lighter color, right? And so that's how it is structured. And again, this is using the National Weather Service data. So we kind of did it for the entire United States rather than just California only. Same way for heat stress, heat advisory tool, where you can select your threshold and it creates the heat advisory map for that location. Now, this crop phenology tool is a little bit more intensive, data intensive. Like, we have crops and the variety specific information, and then it's using that 800-meter resolution data. And for any location, you can track, your growth stages, and depending on, like, which crop we so far, I think we have 12 crops in the growing degree day tool, but we are adding more based on the data that we might get available. Same with the pest advisory tool. So we have models available and we have data available. So this tool will give you an approximation of when their generation would start, when would it end, and so you can use this type of information for scouting, scheduling, pesticide application, etc. So this is more in-season management handy tool, and we try to make it simple as possible that people can use it. And the last one is more about, for any location, what are the changes happening historically. So if you use this tool, you select your location and select this indicator, it will give you last 30-40 years of time series of how things are changing. And again, this is the historical, not anything in the future. So that kind of gives you the snapshot of how things are changing and what are the changes for that location. I'm towards the end, and so in summary, we talked about changes in climate that's already evident in California. Changes in temperature in last 100 years are showing warming trends. Uncertainty in precipitation, extreme events are happening more often, and this is going to continue in the future. Water is a big component, as we all know. It's a precious resource for California, and so I think, how do we manage water well with the crops that we are growing, and we grow so many crops, and so just to give a perspective, out of 100, overall land, if we just put in a percentage, less than 10% of the total California land is irrigated. Yet we are managed to produce, like, the maximum revenue than any other state in United States. So the water is a critical part of this, and so I think it's important. We've seen that crop specific indicators our vulnerabilities are emerging, and I think we need to work on that, and I think providing information that is relevant for growers. From the research point of view, I think we still need to do more to really fully understand what are the really crop specific changes or stress that we have, and how can we manage it well. And it needs to be more localized, and models that we use need to be robust enough. And I think we need to engage with the commodity from the beginning of the process. Thank you so much.
What is the, as Dave avocados, what is the minimum temperature and duration for an avocado to get frost or freeze damage? And is the tree more susceptible to frost freeze damage than the fruit?
That's for you to answer.
So the general rule, it varies from variety to variety, okay? And as a general rule, it's been the older literature, because we've had many severe freezes in Southern California in the past, is about 4 hours at 26 degrees. But in my experience, Ben may disagree. That's the tree, okay? So I'll get to the fruit in a second. So in terms of the tree, my general feeling is if you can grow a lemon, you can probably grow an avocado. Okay, so it's not like an orange or a mandarin, it's more like a lemon. Now, on the fruit, you get different kinds of damage. So if the first thing that freezes is the stem of the fruit. Okay? If you have a very cold freeze, the fruit will freeze. But the outcome of freezing the stem is generally about 7 to 10 days after the freeze, the fruit will start dropping. And the other thing is that then you will actually see the avocado does not normally ripen on the tree. But when you have a freeze and you break that, you freeze the stem, then the fruit will ripen on the tree.
I think maybe you said, what was the minimum temperature and duration for the stem to have damage?
Probably below 32. We don't have good data on that one. The other thing is if you have a late freeze, like if we had a freeze tomorrow, then you're going to freeze the flowers. When you go out and we look at the trees this afternoon here at the station, you'll see the trees are pushing the flowers. And if you have a late heavy frost, it'll burn the flowers. But the avocado is unbelievable in the sense that it'll push flowers way back
That
into the
situation is for any tree, fruit,
Yeah.
blueberry,